Hi, my name is Steve Cook and I'm the inventor of a technology we call DSL Rings. I'm also the founder of a company called Genesis Technical Systems. More about that later. Right now what we want to talk about is the efficiency of utilities and a green plan for a nation. So what the typical consumer usage pattern is of most households is over time you have let's say this is midnight and this is the next midnight. You come along, you wake up, big spike, and then a little during the day it's lower, then you come home after, goes down until bedtime, then it repeats. So basically this type of situation happens millions and millions of times in a big city. So those peaks add up. As many people as there are in the city, and many houses, this happens. And it also happens with different utilities. From the point of view of utilities, they have to design their systems so that they can handle the peaks of demand. And as you can see, these are the types of peaks that happen. So, and they build up. So what utilities would love to be able to do is to be able to incentivize consumers, you and me, to be able to move those peaks or reduce them. Because even if we do 10% less, 20% less, it doesn't mean a whole lot to us. But on 1 million people, it makes a really big difference. So one of the big issues with that, though, is the utilities don't know how or when each person is using their power or their water, gas, etc. What they need is a communications infrastructure. And unfortunately the utilities that's not their core competency. So what they need to do is look to the telecom companies. And the problem with smart grid technologies is that the will is there from the utilities, but there is no guaranteed backhaul for their data to get to that utility. So they have all these nice meters that have Wi-Fi interfaces on them, for instance, that can interface with trucks going around with special laptops and so on. Many of these types of things have been tried. Other utilities are looking at GSM or mobile type signals. These are kind of expensive. Excuse me. So the big thing here is that if there was a telecom infrastructure that could support that, you could have the utilities get the data that they need so they can incentivize consumers during the day to reduce their consumption, or perhaps to move that peak demand into different areas or spread them out, for instance. This would mean that they wouldn't have to build another nuclear plant or whatever, you name it. What happens here is that the telecom infrastructure is old and it's copper. So in the interest of reduce, reuse, recycle, what we do at Genesis Technical Systems, as I mentioned before, is that we have a technology that reuses the existing infrastructure to provide up to 400 megabits per second internet bandwidth on that existing copper. So we reuse the copper, we get very high bandwidth, and as a discussion point, we put on a Wi-Fi interface, and the home gateway portion of our device is owned by the telco. So if the consumer moves, that device stays there. If they rent out the unit to somebody else, that unit stays there. So the utility is guaranteed that they have continuity of information from their meter at that premises. So the way we do it is that a typical telephone network has your central office or exchange, Then you have a big cable that comes out to a big cabinet called, depending on the telecom company you're dealing with, a PCP or an SAI or a JWE or many other different things. And it comes down to another little box on your street corner. That's called a DP or a pedestal. And then it comes out to the individual houses. Now that's maybe 1,000 telecom or copper pairs. That's maybe 50. And these are 2. And this goes to each house. So the way we do things is that there is the DSL has a transmission curve that looks like that, where this is bandwidth and this is distance. Now you can see that this distance here is only at about 1,000 feet, perhaps less. So the point is you have to keep the distance short. Now in this picture, that distance does exist. It exists house to house. It does not exist back to here or back to here, because these distances here are often greater than 2.5 kilometers. So to get that 1,000 feet, which is 300 meters roughly, you can only go to there. So to maximize the capability of the latest DSL technology, which is VDSL2, you have to use it in its most optimum habitat, which is this. So we're going to keep the distance short. We go house to house. And then we still have to deal with that distance. So there's another technology we use. It's called bonded DSL. What that does is it says, take as many pairs as you've got. In this case, let's just say 50. Let's say at this point, because we've gone way down this curve and we're out here somewhere, we can only get, let's say, 10 megabits per second. We take that 10 megabits per second and multiply it by the 50. We now have 500 megabits per second available at that point. So because we're up here, that's 200, and that's per pair. And there are 2 pairs here. We can get up to 400 here. So from this point here, we've got bonded DSL. And at this point here, we have VDSL2 and the short distance. So fine. We've now changed the way the network is architected. We've done this in a way that is totally reusing the existing cabling. There's no new cabling involved here. And we've provided huge bandwidth. And if we put a Wi-Fi interface on here, each of the meters in those houses can be read real time by a utility over here. So basically the bottom line is that you have to have the telecom infrastructure so that, and it's guaranteed to be there, so that the utilities can get access to their meters. We all know the benefits of a green strategy for a nation. This is far more efficient, reuses the existing infrastructure, is relatively cheap to install compared to optical fiber ripping up the streets and everything. And you get the benefit of reducing those peaks. Thanks for your time.
That is amazing bandwidth. How do you know it works?
In the last couple of days, in fact, in the last couple of weeks, we have been to 2 of the largest incumbent telephone company labs in Europe. They know it works, they've tested it out, and we've also demonstrated it at several industry trade shows. Thanks for the question.